two independent random variables x and y are uniformly distributed in the interval -1, 1. The probability that maximum value of x, y is less than half is. So this is the random variable x, and random variable y also follows the same pattern. It's uniformly distributed. So this is the way you draw the PDF of a uniform distribution. What it means is that any value between these two values, -1 and 1, are equally likely, or all the events occur with the same probability. Now the question is, you need to find the probability that maximum value of x comma y is less than half, which means that x must be less than half, right? The logical meaning of this is that x must be less than half and y must be less than half. That is the meaning of that, right? Maximum value of x and y. When you take two values from x and y, you randomly take two values, one for x and one for y. And if you want the condition that maximum value of x and y is less than half, it means that x must be less than y and y must be less than half. I mean, x must be less than half and y must be less than half. So the question is to find the probability of simultaneous occurrence of these two events. The event means value taken by the random variable is less than half. So to find the value, the probability that x takes a value less than half, you know that you have to find the area from -infinity to half. Here you need not bother about the value from -infinity to -1 because it takes 0 value. So your objective is to find the area from -1 to 0.5. 0.5 is nothing but half, right? So this area, now this is a rectangle. This is -1, this is -1, and this value will be half because this length is 2. So the height must be reciprocal of that, and only in that case when you take the total area it will be 1. You know that the total area of a PDF must be 1. So to make sure that the total area is 1, you in uniform distributions, what you do is you find the endpoints, the limiting points, you find this distance and you take the reciprocal of that distance as the amplitude of this particular function, right? So here it is 1/2. Now since that you are going to find the area of a rectangle, you know that what you have to do is you have to multiply the length and breadth. So this will be the probability that x will be less than or equal to 1/2 will be this length into this height. So this length is 1 plus 0.5, which is 1.5, or it is 3/2. So 3/2 is the length and 1/2 is the width. So the probability that x takes a value less than or equal to half will be 3/4. Now y also has got the same probability, because when I go for finding p of y less than or equal to half, that value must also be 3/4 because both x and y follow the same function. Now I have to find the simultaneous occurrence of these two conditions. X is less than y is also x is less than half, y is also less than half. Which means that I have to, since these two are independent random variables, I have to take the product of individual probabilities to find the simultaneous, the probability of simultaneous occurrence, right? P of x intersection y is P of x into P of y. So when I take the product, 3/4 into 3/4 is 9/16. So my answer must be 9/16. Parcels from sender S to receiver are passed sequentially through two post office. Each post office has a probability 1/5 of losing an incoming parcel, independently of all other parcels. Given that a parcel is lost, the probability that it was lost by the second post office. So this is the sender, this is the receiver, this is post office 1, this is post office 2. 1/5 is the probability that I lose it from this particular post office. 1/5 is the probability that I lose it from this post office. Now I need to find the conditional probability. Given condition is that I have already lost the parcel, and I have to find the probability that I lost it from post office 2 when I know that I have lost the parcel. So this is when I mean by P of 2, it means that I lost it from post office 2. L means I have lost it. So I have to find first I have to find the probability that I have lost the parcel. So this is post office 1 and this is post office 2. So a sender sends it Until this moment, there is no chance for me to lose the parcel. So it will definitely reach post office 1. And from post office 1, I lose it with a probability 1/5. Now, from post office 2, actually I lose it, but the thing is that I will not get 100% of parcels which sender S has sent to parcel 1, I mean post office 1, because a part of that will be lost from post office 1. If you have a confusion in what I'm saying is that probability of losing it from post office 2 will be probability that 1 has sent it rightly is 4/5 into I lose it from post office 2. So the chance of losing a parcel from post office 2 will be 4/25, whereas from here it will be 5/25, because this is 1/5, so I multiply numerator and denominator by 5, so that I'll be getting 5/25. So these two things lose parcel in different probabilities, though they are independent probabilities. The way in which if I send 100, I lose 20 from here. If I send 100, here also I'll be losing 20, right? But the thing is that if I send 100, only 80 will reach here. So for that, to think about the same problem in a more appealing manner, if I say that this probability is 100%, and let this be 1/5, 20%. Now, if I send a parcel if a sender sends a parcel, what is the probability that I'll be losing the parcel from post office 2? It must be 0, because whatever I send here, this person is going to, right? This person is going to lose it. So this 1/5 all of a sudden becomes irrelevant, because this person loses everything, which means that it is not the 1/5 that counts, but 1/5 means I need to find the number of parcels which I get here, and based on that only I can say that a part of that 1/5 of those things which I receive here will be lost. So what I receive here is directly related to this particular value, or 1 minus this particular value. So that's why I have taken 4/5 into 1/5, whereas here the sender sends it to post office 1, and it is sure that he will not lose it, which means that it is actually 1 into 1/5, whereas here it is 4/5 into 1/5. If this were 100%, the probability of losing a parcel from post office 2 is 0, regardless of this value. So this probability is 4/5, and this is 5/25. This is 4/25. Now I can lose a parcel from either post office 1 or post office 2, which means that I have to take the sum. So P of L will be 5/25 plus 4/25, which is 9/25. Now in the numerator, I have to find the simultaneous occurrence that I have lost it, and I have lost it from post office 2. So when I say that I have lost from post office 2, already it implies that I have lost it. So I need not consider this thing. All that I have to see is I have lost it from post office 2, because I have to find the simultaneous occurrence that it is lost, and it is lost from post office 2, means that already it is lost. So it is 4/25. My numerator will be 4/25. So my answer must be 4/9. So 4/9 will be the probability with which the parcel will be lost by the second post office, given that the parcel is lost. Continuous random variable x has a probability density function f of x is equal to e raised to minus x, and x lies between 0 and infinity. Now I have to find the probability that x is greater than 1. So I know that this is x, and this is e raised to minus x. E raised to 0 is 1, and it is a decaying function. Now I need to find the probability that x is greater than 1, which means that I have to find this particular area, or it is nothing but integral value of 1 to infinity, because from 1 to infinity I have to find the area of this particular function with respect to x. Now integral of e raised to minus x is e raised to minus x with a minus sign. So to avoid the minus sign, I can interchange the limits. So this is 1 to infinity. I apply the upper limit, e raised to minus 1 is e raised to minus 1 minus e raised to minus infinity is 0. So my answer will be e raised to minus 1, or rather it is 1 by e, which is nothing but 0.368. So my answer will be 0.368. Let the random variable x represent the number of times a fair coin needs to be tossed till 2 consecutive heads appear for the first time. So you need to find the expected value of x, which means that you need to find the expected number of tosses required to get 2 consecutive heads for the first time. So usually expected value of x is, that expected value of x is sum of x into p of x, right? The random variable into the probability of that random variable. So when we take a few cases like head, now here the length is, the random variable is length of or rather the number of tosses required, so it is 2, and p of x is 1 by 4 because one head happens with a probability of 1 by 2, the second head happens with a probability of 1 by 2, so it is 1 by 4. Now when I go for this case, the expected length is 3 and the probability is 1 by 8, right? Because this happens with the probability of 1 by 2, again this happens with the probability of 1 by 2, this also happens with the probability of 1 by 2. If I multiply these three things, I'll be getting 1 by 8. Now if the length is 4, this happens with the probability of 1 by 16. And again, this is another option of having a length 4, this is 1 by 16. So seeing this, you can understand that when you multiply these two things and sum it, it is quite time consuming. It will be quite time consuming, and also it will not be easy for you to find out the series whose sum you can find out easily applying a formula or an equation. So we have to think about this problem in a different manner, and you can apply the same concept in any of similar problems that you will be facing. So here the length is 2, right? In this particular case, I'll write the table here. Here the length is 2 and the probability is 1 by 4. Now in this case, what it means is that first you got a tail, which means that the expected, this becomes invalid because what you require is you need 2 heads to appear for the first time. So since this is a tail, you are going to start the experiment again because you don't have a different option. Already you have got a tail. So from here onwards, you have to find the expected length, and this expected length will be x itself. Suppose if the expected length, if I take the expected length of or the expected number of tosses as say a, I know that if I got the first thing as t, I have to start the experiment again, and hence this length, the expected length from here onwards will be a. Which means that with a probability of 1 by 2, because the first thing is tail with a probability of 1 by 2. So I'll write it here. This is 2, the length is 2, and the probability for that thing to happen is 1 by 4. Now, when I get the first toss as tail, I know that the probability is 1 by 2, and I know that the length a will be incremented by 1 because I have got t. So with a probability of half, I can say that the expected length will be incremented by 1. Right. Now, if I go for the next option, head tail, what it means is that the first thing is head, the second thing is tail. From here onwards again, because since that this is a tail, I know that I have to start the experiment all over again. So with the probability of 1 by 4, I can say that the length will be incremented by 2. Now if I see these three things, I can say that this is 1 by 4, this is 1 by 2, and this is 1 by 4, which means that already this probability sums up to 1. So the meaning is that with a probability of 1 by 4, I can say that the length will be 2. The probability of 1 by 2, I can say that the length will be a plus 1. And with the probability of 1 by 4, I can say that the length will be a plus 2. The expected length will be a plus 2. So I need not consider other options because here when I take tail and tail, already I have the first tail I have already taken. So I am starting the experiment from here again. So this expected length will be a regardless of whatever things I get here. So when I add these three things, I'll be getting 1, which means that this is 100% probable. So either it will be of length 2, or the expected length will be incremented by 1, or the expected length will be incremented by 2. So when I take this expected value, I know that the answer must be 8, which means that I'm going to find the expectation now. 2 into 1 by 4, right? 2 into 1 by 4 plus a plus 1 into 1 by 2 plus a plus 2 into 1 by 4. This must be a, because this is the expected length of the number of tosses, or rather the expected number of tosses required to get two consecutive heads for the first time. So this is 1 by 2 plus a by 2 plus 1 by 2 plus a by 4 plus 1 by 2, which is a. This is half, half, half. So this is 1.5, right? Plus a by 2 plus a by 4 is 3a by 4, which is a. When I take this to the side, I'll be getting a by 4 equal to 1.5, or a will be 1.5 into 4, which is 6. So this is the way you can find the expected number of tosses required for certain conditions. In this question, the question is to find the expected number of tosses required to get two consecutive heads for the first time, and that is 6. The probability of getting a head in a single toss of a biased coin is 0.3. So the probability of getting a head is 0.3. Now I know that the only other option is tail, so the probability for getting tail will be 0.7, right? Probability of getting a head in a single toss of a biased coin is 0.3. The coin is tossed repeatedly till a head is obtained. If the tosses are independent, then the probability of getting head for the first time in the fifth tosses. So this is my first toss, second toss, third, fourth, and fifth. In the fifth toss, I'll be getting head, which means that all other tosses I got tails. So I need to find the probability for such a sequence to happen. So what it means is that the first toss must be a tail, the second one must be a tail, the third one must be a tail, the fourth one must be a tail, and the fifth one must be a head, which means that I am adding it. So since these events are independent, I know that since the probability of getting a tail is 0.7, so the probability of getting tail in the first and second will be multiplication of these two things. Getting a tail in the first three tosses will again be a multiplication of these three things, which means that I have to multiply all these things to get this particular sequence: tail, 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 and a head. So when I multiply this thing, I'll be getting the final answer, which is 0.072. So this is the required answer. So the probability of getting head for the first time in the fifth toss will be 0.072.